Hey guys, today we're going to learn about factoring trinomials. So right now I'm given a trinomial where a equals 1. Right, we're looking at factoring trinomials that are in the form ax squared plus bx plus c. It might not have a ton of context yet, but when we get to quadratics it'll be hugely important. So right now a is 1. And when we factor a trinomial, we want to factor it to two binomials. So it's basically the opposite of what we've been doing, where we've been multiplying two binomials to get to a trinomial, or we multiply a binomial by polynomial, polynomial by polynomial. In this case, we're dealing with trinomials being brought down to binomials. What we're looking for are factors of our first term and of our last term. So we're using a sort of guess and check method to find our factors. Now, for x squared, there's only one thing that can multiply to x squared, and that's x and x. So we're trying to create the two binomials that were multiplied together to give us our trinomial here. Now let's look at the factors of 12. We have 12 and 1, we have 6 and 2, we have 4 and 3. So let's see, we need these factors not only to multiply to 12, but also add to the 7 in the middle. So 12 and 1, they multiply to 12, but they add to 13. So this is out. 6 and 2, they multiply to 12, but add to 8, so they're out. So it's really 4 and 3. So it's x plus 4, x plus 3. Now if one of these factors were negative, that would be minus, but since they're both positive, it's plus. You can check your work on this and make sure that you've guessed and checked correctly by multiplying the two binomials to make sure you come back with the trinomial you originally had. So let's try another one. So we have d squared minus 17d plus 42. Alright, so again, d squared, the only thing that can make up d squared is d times d. So let's look at the factors of 42. We have 42 and 1, 21 and 2, 14 and 3, and 7 and 6. And I believe that's it for 42. So let's test what we have. 42 and 1 multiply to 42, but they definitely don't add to negative 17. So when we look at this negative 17, we know that one of our factors must be negative. And that's really at least. So in this one, we look at our middle term, we see that this is negative, so at least one factor must be negative. Now let's use our minds and our rules of multiplication. When you have a negative times a negative, you end up with a positive. If you have a negative times a positive, you end up with a negative. So these are the ones that multiply. It essentially multiplies to this and adds to this. So since it's a plus, we're looking at two negative factors. This last term, the sign in front of it, if it's a plus, you have two positive or two negative factors. If they're both positive, if this is a positive, they're both negative if this is a negative. If this was a negative, then you have one factor that's negative, one that's positive. In this case, we're looking at two negative factors. So let's try them. We're going to say that they're now negative, so let's make all of our factors negative. Negative 42 times negative 1, still 42, but it still does not add to negative 17. Negative 21, negative 2, again 42, but when you add them together, it's negative 23, which is not going to work. So negative 14, negative 3 multiply, and when you put them together, it's negative 17, and that's how we get our two factors. Alright, so those are the cases that we could possibly see. Let's look at a more difficult example. So how about when a does not equal 1? So we have 2x squared plus 15x plus 7. Again, we need to multiply two binomials to get to this, so we've got to break it down when we factor it to two binomials. Let's think of all the ways that we could get to 2x squared. Well, we definitely have to have an x times x again. What numbers can multiply together to get 2? It's really just 2 and 1. So we're going to put 1 as 2x and 1 as just x. There's no other way to get to 2 through multiplication. And our last term is 7. So our factors of 7 are really just 7 and 1. Now here's what we need to figure out. Where does the 7 go? Where does the 1 go? Both of these factors are positive, by the way, because this is positive and this is positive. Remember, if this were negative and this were positive, then we'd have two negative factors. If this were negative, then we would have one negative, one positive. So how do we get to 15? We need the numbers to multiply to 7, these last numbers, which they do already. We need them also to add 15. So, let's see, if we do 2x plus 1 and x plus 7, will that work? If we multiply these like we do with our binomials, we multiply the 2x, we have 2x squared, and then plus 14x plus x plus 7. And let's combine our like terms to see if we got back to where we're supposed to be. And that's sort of how you do it. You are doing the opposite of binomial multiplication. You're working backwards, and you're making sure it would work out. I mean, you can use your mind to think 2 times 7 is going to get me to 14, and then 1 times x is going to get me one more x, and that'll get me to 15. It's about using your ability to multiply numbers and see that they're going to lead to the point that you want them to get to. Let's try another one. (6x squared minus 17x plus 12). Alright, this one's a little bit different because we have a variety of options for our 6. We could have 6 and 1, we could have 3 and 2. But we know we're going to have an x no matter what. And then, so this is for the 6, that's the a. Alright, so we're looking at the factors of a here. And let's look at the factors of c over here. So this is 12. That's 12 and 1. That's 6 and 2. And 3 and 4. Right? So a is 6. And c is 12. And we're looking for the factors that can multiply and get us back to this trinomial. So let's play around for a little bit. Let's see what we can do. What do we know just by looking at it? Well, we know that we're going to have two negative factors because this is positive, but this is negative. So we got to try that. Now let's kind of test what we have. Let's test 3 and 2. Let's see how it works. So any of those c's multiply to 12. Let's just pick two that we think could get us to negative 17 when multiplied. So I'm going to try 3 and 4 because I know 3 times 3 is 9 and 4 times 2 is 8. And if I do a negative 3 here and a negative 4 here, I should be in good shape. So 3 times negative 3 is negative 9. 2 times negative 4 is negative 8. Again, you could get it wrong the first time. You completely get it wrong and have to eliminate an option. But the better you get at it, the more you start to see sort of the trends and the way the multiplication works, the better you'll get at it. And that's just going to come with practice. So let's check our work. 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. Negative 4 times 2x is negative 8x. Negative 4 times negative 3 is positive 12. 6x squared minus 17x plus 12. Now, one of the reasons I chose 3 and 2 over 6 and 1 when I did this problem was because I looked at my factors and I looked at how the numbers here, if I multiply them, the 6 might make something really big and get outside the realm of our numbers. If you're looking at really big numbers like right here, maybe the 6 would have been a better choice. But I kind of realized that these numbers are not so big, so 3 and 2 are probably going to keep my numbers a little bit smaller, whereas some examples might have a bigger a, b, and c. We'll practice this more, try and do your best to figure it out,